our setup for today's experiment, which is chromatography of ink and food dyes. All right. And of course, the mixture of food dyes. So what we are going to do is we will do first with the ink from the pen or the ink that we write with, and later we will do the same type of chromatography for food dyes. So for ink from the pen, we will just use the very simple and the normal pens that every day we use, so you can relate better of how the color gets separated. And for these three ink, for three pens, we have three different color. One is yellow, one is purple, another one is red, or dark red, you can say. All right, so these three. And then we have our food coloring, food dye. This is violet. And then this is yellow color. And later we will see the much more better separation of this. This is cherry, right? Then here it is amaranth. And as it mentioned in the methodology, this is blue. And this is tartrazine. So all these colorings, right? Colorings and food dyes that will be used, and later on with these food dyes we will use these food dyes that we know the name, like violet or yellow or cherry red or all those things, as a standard to find out the unknown. We do not know what is the unknown, it's only written unknown. So we will compare with those others to find out what is the unknown. And unknown A and unknown B, there are two unknowns are here. So now let's start. Please let me know if you can see my table. Can you see my table and the things that I'm doing?
Yes.
Yes.
Okay, good. So what is the first thing that I should do? The very first thing, I should use gloves. Okay, safety first in the lab. Oh, by the way, have you seen the announcement that those who wants to come for face-to-face, please do the survey. I mean, just take the survey. It takes 10 seconds to do it. Click on it and say that, yeah, I mean, tell your availability if you are available for the face-to-face session that we will start after the mix and break. Okay, so what we are going to do is we will take around 250 milliliter beaker, these beakers, but we are not going to use the beaker. We have modified this thing. This is a plastic jar we'll be using because it has a cap, so we can cap it, right? We can cover the surface. We'll be using this and the sodium chloride. So sodium chloride is a polar solvent. The sodium chloride, it can be divided into sodium and chloride ion. So it is a polar solvent. So what we'll do is we will take sodium chloride inside and until 1 inch from the bottom, like 1 inch, so that our chromatograph paper, here it is, the paper, chromatograph paper, it can be dipped inside here. All right, we'll do that. But before that, what I'm going to do is I will take the what do you call it, the sodium chloride, the solution, a solvent, in fact. Give a good shake. Take it. So it is almost 1 centimeter from the bottom. And now I will place it. Just let me check whether it is how much it can go in. I need to make an estimation how much it can go in, and I see that it will be upward. I have to make a line where I will put the sample. All right. So from there, I'm not sure whether you can see. I'm trying to make a line. Trying to make a line up here. Do we have a ruler? It's not here. So try to make. Hold on, I need a pencil because I need to make a line with the pencil. Okay. Yep. I have found it. Now I can estimate, measure it accurately. And this is, I see that I have taken actually more than 1 centimeter. It is about 2.5 centimeter, but it doesn't matter. I can anyway. Let me. Okay. 1.7 from bottom, so that mark here. Then position I mark, I make a straight line where I will put all the samples together. I'll show you in a bit after I'm done. How do I put the samples here? So I make a line, a straight line. This is be my original line. All right. I'm going to put the samples here. All the 3 pen first, putting here. So these 3 pens I'm taking, and I'll show you again how. Let me put the color first. Violet. So I write V here. This is red. So I write R beside it. And then this is yellow. And I write Y beside. So Now you can see that I have put violet this side on the same line, and then red and then yellow on the same line. And I'm going to dip this paper until this level so that it touches the line that I have drawn. And beside the color I put, I just put the first letter of that name of the color, yellow, Y for yellow, R for red, V for violet. But can anybody tell me why did I use pencil? I could use a pen to write the color, right? Anybody has an idea why did I did not put a pen to use? Now I have immersed it, or I bring it in here, right? I cannot bring it, I cannot move it. Can you see? Is it clear? Can you see? I mean, if not even clear, but can you see? The level almost touching the level that I draw, and then you see the color start to go up, starts to go up. It's climbing, looks like it's climbing, and at some point it will get separated.
So we cannot see the line itself.
Yeah, I mean
It's too
the
low in
line.
the camera.
The line I drew it with the pencil, so it is a bit faint. It's still to me faint. So
No, so it's out of frame. It's not in the camera. We can't see the lower part of the bottle.
oh, okay.
Yeah.
So, all right. Now is it better?
Yes, sir.
All right. So I think now you can see that the color starts to get separated. Not separated yet, but it is moving upward. It's moving upward. And I will wait for some time for it to get more separated, right? I can see the solvent front just maybe 2 millimeter above the line of the color, but yeah, you will not see. But I think you have started to see the separation of the colors for some of them. I'm not going to tell what is different, but probably you will be able to see or distinguish the color separation. And now anybody can, I mean, maybe ask me that, okay, how long do you wait? Well, it depends, but we give some time, like 5 minutes, 7 minutes, like that, till we see that, okay, colors are, I mean, solvent front is much higher than the color front, so that we know that, okay, this is the time that we should stop. But for me, I still see that the color is moving with upward with the solvent. So it is still has a chance that it will get more separated as it goes upward along with the solvent. And that is why I'm not stopping yet. One, I mean, interesting thing is that, okay, among you, do you see, I'm sure that you can see it very clearly now, but do you see any interesting thing here among these three? any interesting thing? I mean, does it tell you any interesting thing? Or do you see that there is an interesting thing here happening?
So it's again not a frame. It's a little too close to the bottle now. We cannot see
Sorry?
the color. We cannot see the colors at the bottom. Yes.
Really? But
Yeah. Now we can see.
okay.
Yeah.
So yeah, can you tell me what is the interesting thing here? What is the interesting thing that is going on here? Or does any of this thing looks interesting to you? There is actually, you have to see it clearly so that, or more.
Looks like the pink color is at the bottom is almost all gone.
Exactly, that's the thing I was meaning actually. And there is another thing is probably there is something with the yellow you can see. Yeah. So the pink color here at the bottom looks clear. That means it's moving upward, right? It is moving upward along with the solvent, and that is interesting thing. And the solvent is polar, right? So, and you will see the similar trend with the red color. The top part of the red is actually pink. Is it pink? Violet, yeah. Okay, is pink color, right? Or violet color, this one.
Looks pink.
Okay, yeah, whatever. So the same color, you can see that the red has it and it is on top. That means it should be the same pigment. Pigment means the component that that makes the color. The color is made of different pigments. So this red should have the same pigment here. That is why that this in the top. And red has 3 different pigments, whereas this violet has the same, almost similar. There is not. Oh no. So that violet has only one similar single pigment. The red looks 3. The yellow is also, maybe there are 2, but we have to see it very carefully to find 2. But anyway, we can see it. Yellow has, okay, it's up to you. How do you want to interpret it? How long are we doing this? Did anybody keep the watch? I think I'll do it for another 4 or 5 minutes. But for that, just let me prepare for my second experiment so that finish faster. Okay. So for the second one, I'll do the same thing. I'll take like 1 centimeter from the bottom of sodium chloride. So this is sodium chloride solution. The same thing, the salt, table salt that we use for cooking. Yeah, it's 1 centimeter. I'll, to be more careful or more sure, I'll just do a little check. 1 centimeter from the bottom. And I'll make a straight line from the bottom. I'm using pencil because pencil, this graphite does not become separated in chromatogram. So that's why I'm using pencil. And now I will be using all those 6 different colors here. right? Before that, let me write the name of the color so that later it will not be confusing for me. So it will be I have to do two different setup because we have 3, 3, 6, 8. I'm not sure whether I can take 8 of them. Let me say amaranth is A. Then I have another one which is blue, E. Then I have another one, tertazine, T. Then I have another one here, food dye, violet. Then here it is yellow food dye, Y. Then I have cherry red, C. And then unknown, how do I, okay, A1. A1 is unknown, yeah? And then B1 is also unknown B1. All right. So this is set up. I'll just put the dots later and put it inside. So I have 8. I will get 8 different bands. I think I'm enough. We have waited. I think we have waited enough, and the pink color also stopped climbing. I don't know whether you can, I hope that you can see. Right, the pink color seems stopped climbing and the solvent front is quite much, it gone up. So what I'll do is I will remove it and keep it for drying. But before I keep it, before I put it for drying, what I'll do is I will mark where the solvent front reaches. So later on, we can calculate the RF value from that. Put my phone back here. Solvent front reaches here, SF. So this is the band it looks like. I hope that you can see. This is the solvent front, okay? The solvent front, it reaches, and later on, we will, after it becomes dry, it's very soft now. I'm scared it will tear off. So later on, we will find out what is different color and with the ruler, how far it reaches. I will just leave it for dry, maybe 5 minutes should be okay. Right now, as I was saying, that I marked this place. Can you see? A, B, T, V, Y, C, A1, B1. Can you see?
Yes, sir.
Yes.
Yeah. So A means amaranth, B means blue, T means tertazine, V is violet, I think. Let me check. V, yeah, V for violet, Y for yellow, C for cherry red, and A1 and B1 at the end on the top, extreme right side, are for unknown A1 and unknown B1. So just to show you that this is unknown, we have to find out what is unknown based on this. This is unknown A, unknown B, right? So based on their RF value, what is unknown? Now I am going to apply. I'm going to apply the color here with the help of this capillary tube. Can you see the capillary tube? This is the capillary tube. It's a very thin plastic glass tube that I will take a little bit, only a small amount of those food dye here. So I'm dipping it inside, and it is so small, tiny amount. I'm putting it on V. Violet should go to violet. Okay, violet is violet. Then yellow, I take another one. I'll show you later on because I'm using my both hands. I cannot hold my camera now. Yellow should go to yellow mark. Violet, yellow, and then I use the amaranth, another different capillary tube. I broke the capillary tube, and where did it go? God, it's dangerous. It's very sharp. Amaranth is going to A. A. Cherry is going to C. Okay, cherry is at C spot. Then now I'm going for blue. It should be at the B spot. All right. And then this is tertazine, should be a T spot. All right, now it comes for my unknown A and unknown B. So I put unknown A first to the spot where I designated or where I wrote A1 for unknown. All right. Oh my God. The unknown 1 and unknown B. Also, I need to put it here. All right, so I'm set now. I'm showing you. Wait a bit. Let me just make it a bit tidy. All right, hold on just a second. All right, so I'm set. I spill a bit of the solution. Clean it up first. All right. Okay, so I can show you how it looks when I put. So I'm not sure whether you can see. Let me turn on my flash, whether it will work. No, flash does not work. I don't know, but I hope that you can see it. Okay. Let me take a photo, in fact, so that I can send it to you later. Okay, so I've taken a photo. Hopefully, I will send it to you. Oh, by the way, this time the experiment. Hello. Just hang. Hello.
So we can hear you, but the camera is frozen.
It looks like it is hanged. My phone.
Oh.
Okay. Yeah, now should be okay. Yeah. Yep. Can you see?
Yes.
Yeah. So this is what it looks like before I put it inside the solution. And now I'm going to put it inside the solution. All right. So hold tight. Here it is. I'm going to dip it inside. fall down. That is why. All right. Now you see that immediately it starts to separate. Can you see?
No, sir.
Huh?
We cannot see, sir. It's too low. So if you move it further back, I think we'll be able to see it.
Further back or towards
Yes,
you?
now?
Now?
Further away from the camera, towards the red color lid, the second one on the back.
You think better this way, yeah?
Yes, sir.
Yeah. So you see that immediately it starts to separate. I'll give it to some more time, maybe another 2-3 minutes, to see how far it goes. Who are winning in the race? B and B1, it looks. So I see that they are separating nicely. And we have gotten quite good spectrum for A, B, T, V, Y, C, A1, B1. A1, B1 being the unknown A and unknown B. It looks that we should stop because it has given us quite, the color has been separated and it looks like it will not separate any further because I can see the solvent front has reached much further than the color front. So I think I'll stop. I'll take it away out from the solution and then I will put it to dry. And by the time I'll check the previous one for the ink. All right, so let me put my phone back and then I will stop it, move it out, mark the solvent front. I mark the solvent front faster, otherwise it will be a problem. SF is the solvent front, so I leave it for drying. Do a little bit of housekeeping here. should be okay because it is a food dye, so it is water soluble. Right. Right. Now I'm going to bring the first one of our thing. And interesting thing is, after I have left the solvent front increased a bit, and still the good thing is, I still can see the solvent from front reached to some extent. Let me delete the Okay, so now you can see that this is for the ink, okay? And here we have, let's say that we start from the 0 millimeter. We started, hold on, yeah. Started from 0 millimeter and the solvent front reached there. So this is what we have gotten. Yeah. The solvent front reached to, oh, hold on. I go and bring a one white paper so it will be better. So here you go. Now it's better, much better. So we started from 0 and then the solvent front reached to that 8.4 or 8.3 probably. 8 point almost 4, yeah, 8.4 it reached. So there are 3 different colors and the violet got separated. R shows that it has 3 different bands, and then Y shows that it has 2. At the beginning, Y seemed like it had 1 only, but now it looks like it has actually two different band color. Let me take a photo. I'll send the photo later on. And for this experiment, the data given to you guys are actually the data from this experiment today. Okay, so everyone will get the same data, but you will have to have your own discussion. Okay, so it is done. Now we go and see. Now we go and see for what is happening with my second experiment. Same thing goes as well. The solvent front increased. And the good thing is I can still see the solvent front up until this position. Okay. This position. And solvent front actually reached quite high. Let me mark with my pen because it is so faint, the pencil you cannot even see. So with my blue ink color pen mark, it is the solvent front. All right. And only one problem. I put this mark here, but this blue color looks like blue color moved up a bit after even I left it for drying. So there is, but still we can see that is the blue color was going forward, upward, which is very much similar to this B. It depends on your discussion, what you want to do. And I see that the solvent front actually reached to 5.5, whereas this blue color front, it reached until 5, which is similar to this blue as well. Same height it reached, this blue. So, and this red looks like very much of this red and this one as well. For V, it fainted too much. It has pink color and then a little bit blue, sky blue, or probably something like that. So yeah, it's separated. Okay, so I take the photo of this as well to send you later. Take the photo. Why I cannot take a photo with clear focus? Okay, I think it's enough. Good. Now again, the camera becomes freeze. I have to turn it on and turn it off again. Okay. So this is what happened when I do the food coloring with unknown color. So from this unknown color, the solvent, I mean, RF value of the unknown color, you should be able to, to find out the unknown color, what's the identity of the unknown color. And you need to do the discussion in the discussion section. Okay, so this is it for today's lab. Any question so far?
Excuse me, sir, what would the possible cause of error be for this experiment?
Sorry, I didn't hear you clearly.
So the possible causes of error in this experiment.
Oh, there. Okay, for what did we do? We mark it from the bottom, right? We mark it from the bottom, and then we are supposed to put it at the same distance from the bottom of this. But when we put, I'm not sure whether I was too precise to put it on the line, exact same distance. And then when we left it, I put the mark here, solvent front, but solvent front reached up to, it crosses that. So that is one problem. Other things are that the solvent itself, whether it was a good solvent, appropriate or not, and whether they got mixed between them, right? So you find it out by yourself. Think of yours. You ask me, I know that you have to think it up by yourself. Yeah? What are the possible sources of possible error that occurs? Okay, so any other question anyone has? No? No question? Okay, if no other question, then I think I'll stop here.